Hello everyone and welcome back to Python Fundamentals. In this class we're going to be talking about inheritance. So again, if this is the first video you're watching, you should watch classes part 1 first, not before classes part 2. Remember, my approach is a very linear approach to learning how to become decent in Python. And all of my video series is going to have that same kind of format. So again, this video is talking about inheritance based on what we talked about last time. All right, so inheritance is pretty much it's a powerful feature that allows you to have access to a class because you are born from that class. I think the best way of inheritance to talk about it is to talk about it like families. Like, you have the father, you have the mother, then you have the child, then the child has a child, but so the child comes from the father and comes from the mother. So the child inherits from the father and inherits from the mother. So there's features about the child that are unique to the child that will be in his class, but there's also features that child has access to from his parents that is him as well. So that is the principle of inheritance: is the ability to create a new class with it having either attributes or functions from a class that it came from. And once you wrap your head around that, you'll understand the concept of inheritance. And honestly, in my example, I wanted to use like an animal. I used an animal reference. This is what we're going to use today because I thought about this one. Because inheritance is something, I think when I first learned inheritance, I didn't grasp the concept quickly. So I want to make sure I show an example that kind of helped me grasp the concept, and it's pretty much just using animals, an animal class, a dog class, and a cat class, and them actually having inheritances between the two. All right, so let's get it. Let's get started. Again, we've got the beginner part, has a little write-up. So inheritance is powerful, provides code reusability because you don't have to create. Every time you create a new class, you can have one class that has the functions and variables. So when I create a new class, I don't have to have those functions because they're derived from the old class. Therefore, it makes the code a little bit more reusable. Make it a little easier to read the code, especially read the code of the classes that were derived, so you can see only the functions and features that matters to that class only. You can have superclasses. That's how you use superclasses to have access to the derived class. So the class that's the child to have access to the parent need to use what they call a super function. You can have subclasses and so forth. Again, child inherits from the parents. The inheritance come from the picture of the is a relationship, right? So they're talking about the child has a relationship with the parent, so it is a relationship. So example, student is a person. So like child is a parent. The child is a person. So I guess in that one, parent would be a person, but the parent. So the child is both have access. It is part of a parent and part of a person. So it is a person and a parent. So it has that type of access. Again, all right, let's get started. I think it makes more sense once we start actually typing. All right, so we're gonna create a class. Let's start with let's create a parent class first. We're gonna call this class animal. Parent class. So we got a class called animal. We're gonna use the class keyword, type in animal, and then we have the colon, and then I'm gonna create a constructor. Def underscore underscore init underscore underscore open parentheses. Remember, I say I always put the self variable first, and then for this class, I want the inputs to be a name for the animal. We're gonna put that in the home class. So the animal, every animal will have a name, and every animal will have a weight. So we want those two variables to be in the animal class because when we create a child, these two we won't have to worry about of creating. Okay, so I will say name, comma, name is the first argument, and then weight is the second. Remember, self always go. All right, so and then in here I want to say self dot name is equal to name. This is my coding paradigm. I always make my self variables be the same as the input variables, so I'll know how to access them. This is not required. You could have said self dot whatever you want it to be, but that's just not my coding paradigm. So don't look at the way I'm doing this, where the self dot the name and they're equal. Is that's like I have to be. That's not. You can change that. I would just suggest using that paradigm, but do what you think is best for your programming paradigm. All right, so weight is equal to weight. So I have those two variables. They're gonna come in from outside. And also I want to make a function. I don't think we've had a function that we actually called. Let's create another function, and all this function is going to do, it's going to print out the animal info. Like when you call this function, it's like the animal telling you its information. So we're going to create a new function called animal info. Remember, you got to pass in self. Just do it automatically. And I don't want to need anything else. We'll use the variables we got. So we pass in self colon, and then we'll print my name is, okay, and I close that. Then I want to pass out self.name, because that's what my name is. And then I'm also going to say and I weigh, and then another colon, comma, self dot weight. And this will be a really good example, easy example. Again, let's make sure you understand what I've done. So I created an animal class that when you create the class, you have to give it a name and you have to give it a weight, okay? And then when it creates the class, it assigns the name variable to name and the weight variable to weight. So all of this is doing is just printing out, when you call the animal function, this function, it just prints out the name that you actually set. So let's run it. It'll make more sense. So we create the class, all right? And this is going to be our base class, but right now we're just going to use it as main class just to show an example. So if I say, I'm going to say ANI for animal is equal to the animal class. And then I'm going to pass in my name, Michael. So I'm the animal named Michael. And then I'm going to pass in, I just got to delete this extra stuff, my weight. And I weigh 230 pounds. So when I create this, I shift enter. This class is created and it has those variables. Again, if we go and click, you should see them. So you got the animal, it has a method. And then it tells you that you have a string with that size 7 in Michael, and then a weight that's an int, that's 230 pounds. So now when I call the animal function, what's going to get printed on the screen? So if I say ani.animal info, shift enter, it says my name is Michael and I weigh 230 pounds. So it calls this function when you do this. All right, so that's good. We have this animal class. So to show the power of inheritance is that, say if every animal is going to have this, if I create an animal, another animal that's a class like a cat or a dog or a rat or whatever, I don't want to have to actually have to create these two variables or this function every single time, because everything I create after this is going to use these three functions. So in your coding paradigm, if you're working on something and you start seeing your create classes and you add in the exact same stuff in all the classes that are connected, that's a sign that you need a derived class. You need a parent class. So it'll make your code more reusable. So say if one of those classes you accidentally forget to copy something from that class, and now that class is broken, and you're spending hours and hours trying to figure out why it's broken, so you can actually solve the problem. All right, so let's do that. We're gonna create a class, two more classes. We're gonna create a cat class and we're gonna create a dog class. And the only thing that's going in each class is gonna have one function, and they're gonna have a yell, like a bark. I call it yell because you can't say bark because cats don't bark and dogs don't meow. So I'm just gonna call the function yell, and then we're gonna get it to print out like it's trying to yell in its own way, like a cat meow, dog woof, bark, 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 or whatever. I forgot. I think it's woof, woof, woof in my notes. All right, so let's do that. And they're both going to derive the animal class. And so by default, when they're created, they're going to have access to two functions and two variables without actually having to have those extra two variables in them. So for instance, let's do this. So I want us to create an animal. We're going to create a cat class. But when we get to this point, this is the only thing new. You have to open brackets and pass in the class that it's deriving. In this one, we're deriving, not, I'm sorry, I didn't mean to mash tab. You don't have to pass anything, it's attributes. You just pass the class name and then do colon. So when you do this statement here, this is saying create a class called cat, but its parent class is animal. So now when it's getting created, it's going to have access to these things. Okay, so when we inside here, I said I wanted to create a function def, and I call it Yale, and I'm gonna pass self. I mean, you have to pass self every single time, and when it's called, it's gonna print, you know, a big old meow, meow. Cat just say it really loud, like a text D&D book, and then that's that class. Okay, so I'm gonna do the same thing. I'm gonna do shift enter just to make sure I don't have any errors. Alright, so that class has been created, and I'm gonna do the exact same thing. I want to create a dog class. Same thing, I'm gonna pass animal. And then it's gonna have the same type of function, yell. And the reason why they both have yell is because the yell of a dog is different than the yell of a cat. So print, and then here we're gonna do woof, woof, and woof. All right, and then close that up. All right, so they both inherit the shift enter. They both inherit the animal class. So when we go create it, we're gonna create the dog and the cat class, right? But because we inheriting, you know how like the animal class required that we pass in this what you call it, the name and the weight of the object. So when we create the classes, we have to pass in the name and the weight because they're going to be expecting it because they're derived from the animal class. So when I say my cat is equal to the cat class, cat, open bracket, you see when I open it up, it's expecting name and weight, and that's because it's deriving from the animal class. And because the animal class needs name and weight, we have to pass it. So I'm gonna have a cat name. I'm gonna call the cat Snacks. Just made it up. And Snacks weighs, we'll put it in as a string because that's how I got it set up on the print statement. Snack weighs 25 pounds. Okay, shift enter. Now Snack is in the scene, and now I want to make the dog, my dog is equal to dog, and we're gonna call the dog Barky. I know that sucks. Barky, and Barky weighs 200 pounds. All right, so now we look at my cat, and you'll see now my cat has in animal info, it has name, weight, and yell because my cat is derived from the animal class. And you see, you can call my cat name and weight and animal class straight up because it's derived. It's derived for that. You don't have to call the animal class. This is how you access the variables for the cat class. So for instance, even though when I say print info for cat, my cat dot animal info and shift enter, it says my name is Snacks and I weigh 200 pounds, and my cat dog dot animal info, I must have put, oh, I misspelled dog up here. I put DYG. You know what? I keep it DYG just to keep it from. But the mistake was I misspelled dog. I called it my doy, I guess. If I do shift enter, it says my name is Barkley and I weigh 200 pounds. So the beauty of the inheritance is that inside of cat and inside of dog, we didn't have to put anything about animal info, about name, about weight. They have access to all of that stuff without doing anything else. So if I were to say my cat dot name, shift enter, snacks get printed back. My dog dot name, Barkley gets printed back because those were stored based on the deviation of the animal class. All right, so I'm trying to think, is there anything else? I guess the only other thing you can have if I'm just here thinking, you can have multiple inheritances. That's kind of like the father, mother, son example I gave earlier, where you have like a class that has variables for the father, a class that has variables for the mother. So when the son information is taken in, it has access to both what the father has and the mother's name. So when you create it, you can have a class that when you create a son, once you pass in, you'll have access to set up the father's name stuff and the mother's name stuff through the son's class. Have access to their inheritance variables and to be able to use them. You know what? Because I said all of that, I might as well go and show an example. Otherwise, I just sit there and confuse you for no reason. So let's talk about multiple inheritance. We'll just talk about it real quickly. Again, this is an intro video, and that's the reason why I was kind of wishy-washy on if I should talk about it at all or not. Let's see. ENH. Let me make sure I remember how to spell inheritance. ENH. ERITANC. All right, multiple inheritance. So for instance, say we had a class. Oh, I didn't mean to put this here. That would be even more confusing. I'm gonna move it to the bottom. Put this down here. All right, say we had a class, like I just said, we'll call it father. So class father, and then and the constructor underscore INIT underscore self, and all it is in this class is just gives his name. So self father name is equal to I need to pass it a name. Do I need to pass? Yeah. Let's say let's call this name, and so father name is going to be equal to father name. So I just want to be able to store the child's father. Okay, so all this is going to happen. It's going to when this creates, it's going to expect. Oh, I must have made a mistake. Oh, I forgot the colon. So shift enter. All right, so right now when this gets created, it's going to have a variable that's father name that you actually passed in if you create the father. But if you just do this as a derived class, you'll pass it in after you create the son. So it'll be just, it won't be created. The derived class doesn't get created instantly, but like, what's this word? You don't need your constructor doesn't get really used the same way in a derived class as other than the class that you're actually creating. But again, I'll stop talking and just show the example. So we created a class of the father. We have a constructor that takes in the name, and then that name is assigned to a variable called father name that we're going to use. Okay, we're going to create another class called mother, just like father. It's going to have the constructor, open up, self gets passed, common name, exact same way, colon, and the difference is we're just going to call this mother's name. so we can make sure we know whose name is who when we use the son. Okay, so pretty much same class construction. All right, so now we're gonna create a son class now. You know, son has a name, but in the son class, the son can take in both the father and the mother. So you just use a comma. And the son has the same, takes the father and the mother, and then it has a constructor that has a name. All right, so def underscore init underscore open self. And then in here, self dot name, the son's name is equal to, oh, I need to put name. I put it there first, and I'll go back up here and put it here. That's why it's complaining, because I have it here. All right, so I just cleaned out syntax. Son, mother, colon. Oh, again, man, we got the colon again. So what's happening? I keep forgetting to put the colon, because every time you end, like when you do have to do indentions, it requires a colon before an indentation in any form, whether it's a control structure, class, function. Sometimes I just be moving too fast and forget to put the colons. All right, so with this example I wanted to show you is that now when we create the son class now, so my son is equal to son, the son class. Oh, I forgot, it's telling me I didn't put in the name, because son requires, the constructor of the son class requires a name. It's called the son. I'll use me. I use my parents' name. So I'm a son. My name is Michael. Okay. So when I do shift enter, when the son comes up, my son, if I open it up now, you'll see it says has the string Michael, and that's what's in here. But because it's my son, and it has two derived class, it has access to the variable inside the father's class and access to the variable inside the mother's class, even though you don't see it up here. Now, I haven't really looked through this. I ain't sure how the I don't sure if the visualization shows anything when you do anything with the derived class themselves. So you don't have any way to see this because this only has my son and my son.name, right? But inside the code, you do have access. So if I go to my son and set, so for instance, if I were to say, I guess we need another, let's put another function inside of here that prints out, so we can print out the name. It'll prove to you that we have access. So I want to create another function that says, let's call it parents info. Parent info. Okay. And for parent info, do I need anything? Oh yeah, you gotta have the self. And then all I want to do in this function is just print. It's just going to print out my father's name and my mother's name. My father name is, and then comma, comma, then I can say self dot father's name. You see how it pops up? Because even though son doesn't have father name, because it's inherited, it has access to father name. It has access to this father's name. So I double click on it, and then I put that like that, and then I'm just going to copy this and rewrite it. Mother name, my mother name is, and then I just changed this to dot mother. See that? Now we got mother. Mother comes from here. So now when I rerun this, shift enter, I'm going to rerun this just to restart it up so to get the changes. So now when I do my son dot father name, I can set it. So I'm gonna say my father, first father name. My first name of my father is Dillard. So I do shift enter on this. And the first name of my mother is Lucille. I do shift enter here. So now as the son, I have access to those two. Because so you remember I set it that father is equal to this. That means I'm using this. I'm setting this variable in father class that I've derived, and I'm setting this variable that's from mother's class. So inside of here, it has a copy of these two, and it's set those variables for this. This is very important because what if these have functions and stuff that they do special? So by doing just a little setup with the son, you can have all the stuff set up for the father and the mother as well. Because you know every child will could have a different father if I was building a class structure for like a school or a high school or something. But now when I call my son info, my son.info, I think that's what I called it. Is it info? Oh, parent info, my bad. Parent info. Shift enter, and it says my father's name is Dillard, my mother's name is Lucille, and it's printing these two out from the self that's stored here, because you know you don't set nothing in the son, it's only set in the father and the mother. Okay, so I think at the basic level of classes, that's all. You have everything you need to know about a class. Let's do a recap, small recap. So what we did today, we talked about inheritance. We created a parent class, and then we created two children's class, and I talked about how you can pass in a single inheritance where you pass in and have access to the attributes and functions from the parent class. And then at the end we discussed multiple inheritance. It's pretty much the same thing, except now you, instead of just inheriting from one class, you're inheriting from two classes. And you have access to their functions, their variables, as well as yours. And that's that. You don't have to do the constructor of your parent classes real time because you're actually constructing the son. So it's assumed that the son will set the variables that's required for the mother and the father's class before they're actually used. That's kind of like the assumption that's being taken in the in the coding concept. It doesn't call the constructors when you open up the son. It only calls the son's constructor. So it assumes that once you create a son, any requirements for the father and the mother, which in this example is just their names, to be able to be used, will be done by you, the person who's done who created the inheritance construct. So just remember that. Again, thank you for watching this series. Class is part 2. I hope it was helpful to you. Again, I hope you have a blessed day and happy programming.